Okay, welcome to Lesson B. We're going to talk about the angles formed by parallel lines and the parallel line rules, because we have rules we use with parallel lines. So let's get started here. So first of all, when we deal with parallel lines, we deal with what's called a transversal. So that's our first definition. So a transversal is any line that will cut through two or more other lines. So it's going to intersect other lines, okay? Phones down, following along your notes, please. All right, so is this a transversal situation with parallel lines, the first object? Are these two blue lines parallel? No, they're not. If they were parallel, they would have the exact same slope, and they would have these little arrows on the line. That tells us that they are parallel, okay? So they've got to show you parallel lines. So a transversal is any line that's going to cut through. So what I like to think of it as is a street and different sides of the street. So it's like a road passing through two other roads, okay? So we got Main Street, and then we've got the road that goes to McDonald's, and then we got the road by the beach. That's basically what we're talking about, okay? And this big long drag, 50th, okay? That's our transversal line in our situation. So interior angles are the ones that are on the inside in between the two parallel lines, okay? So they're the ones that lie in between them. That's the key there. Please follow along. Over here, exterior are on the outside of the parallel lines, okay? Now, every rule matches here. So we actually have 180-degree rules we can do. So what do you know about A and B here? They form a straight line. So what do I know about A plus B then if they form a straight line? They equal 180 degrees. So A plus B has to equal 180 degrees. And then what does that mean about C and D? The exact same thing, because they also form a straight line. So that means D plus C also has to equal 180 degrees, because they form those red lines I drew. Now let's take a look at the other situation. I actually put them in Okay, so now we're going to take a look at the transversal line that cuts through the middle. So the red line is the road that goes to McDonald's. The other red line is the beach. We got the line coming here through them, that other red line that's cutting the other two. That one's our 50th Street, okay? So we've got ones that are on the left side of 50th Street. So the east side, we got some on the west side. Okay, that's basically what's going on. So because, I'm just going to put it in a different color, so this is going to go black now. That makes a straight line. So because of that, A plus D also have to equal 180 degrees. Because vertically, they would add to a straight line. Those two on the left side. And that also is going to hold true for the two on the right-hand side of the line. So B and C will also add to 180 degrees. Okay? Now, that's going to hold true for E and F and G and H. E and F form a straight line, so E plus F has to equal 180 degrees. And same with H and G. So H plus G also has to give us 180 degrees. Okay? Now, if I were to take this part here that I'm going to highlight, if I were to take that part and remove it, that would squish those two lines together. And by doing so, everything on the left-hand side of the line is going to add to 180. So that means E plus H has to give me 180 degrees. And that also means that F plus G has to give me 180 degrees. And again, it's from that simple principle that more than one angle will add up to 180 straight lines. That's that supplementary angle rule. Okay? All right, so those are all true statements. Okay, so we're going to be comparing different statements. So now we're going to talk about a different definition. Corresponding angles deal with what side of the street you're on, okay? So you're either on the west side or the east side of the street. So on this one, they're on the same side of the transversal, and they're identical, okay? Identical means congruent. So they're on the same side of the line, and they're identical size. So that means this right under here and that right under there, they will be the identical same size, okay? And that's because they're on the same side of a line, okay? And they're both under the line, okay? They're both under the parallel lines. Now, what do you know about the ones above it? What do you think about the guys above it? Those are also called corresponding, those red dots. So the ones below the lines will match below the lines. The ones above lines will match above lines. Okay, so a lot of this unit is matching lines to their angles. All right, the same is going to happen. It's a mirror image on the other side. So the same is going to happen on the other side. So if they're on the same side of the street and we're comparing them, and if they're identical in size, that means we call them corresponding. So the red one, if I said the red one is, let's say, 81 degrees, well, that means this guy here is going to be 99 degrees. Okay? Because the red plus the blue has to give me how big? 180 because they form a straight line. Okay, which other one is going to be 81 degrees? Which other one's going to be 81 degrees? Well, 81 degrees is the red dot, so which other one's going to be 81? The other red dot. Good. So 81 is going to match that guy. And 99 will match the other blue dot. Okay? So they're on the same side of the line. Now we're going to take a look at a couple examples. So they're telling us that this one right here is 152.2 degrees. If that is true, then that means this one is exactly the same size. I want you to find how big would the other corresponding angles be. So how big would those red ones be? And how would I find that out? So what do we know about the red dot and blue dot? What would they have to do? They would have to add to 180. So these two here have to add to 180. So all you really need to do is take 180 degrees and minus the other one. 125.2. So how big are our red dot angles? 54.8 degrees. Good. So 54.8 degrees is going to be our red angles. Okay? And that's from subtracting here. Okay? All right. Now, can we find the angles on the other side of the line? Heck yeah, absolutely. So what we're going to do is we're going to identify the ones that are going to match. We're going to put that in the same colors. So if you've got colors, use colors. If you want to draw stars and dots and whatever else to identify, that's fine. So the blue one over here is going to match identically across. Across is the opposite rule. The opposite rule means this guy's going to be the same size. Okay, remember, across an X. So this guy across an X, letter C, will also be 125. So what do we know about the other two small acute angles? They will be opposite. They're going to be exactly the 54.8, okay, because they're across. Okay, if they're across an X, they're going to match identical. Okay? We can do the exact same thing with the second example. But we're going to take a look at the third example. So I've identified in red the section that the angle is talking about. So the angle they're talking about here is 47.5. But the one I want you to find is that angle. How can I find that one if I know both of those? There's two different ways you could do it. Any ideas? Perfect. So find straight lines. Your first thing to always do is find a straight line or a triangle. We don't have triangle diagrams, so we find straight lines. So we're going to find a straight line. One of them's right here. So that means B and the red piece have to add to 180. So I'm going to take 180 degrees, and I'm going to minus that 47.5. So how big is my blue section there? Good, 132.5. Perfect. All right, and again, it's going to have an opposite one. Now, because these are made by parallel lines, because they told us they're parallel, they should have little arrows on them, so we should have the arrows for the parallel lines. They do need them. if I asked you to find this angle, and this angle, am I able to do that from knowing the top? Yes. It will be identical. Every single thing up here on top is going to be identical to what's sitting right here. So we're going to have the small angle is going to be the 47.5. Okay, 47.5. Opposites are identical. Then you've got the guys across, the bigger ones. They're going to be 132.5. So just knowing one of them, you can find the other 7 angles. Yes, there's 7 of them. Because we've got 3 up here, 3 other angles, and we've got 4 down here. So once you know one of them, you can find 7 others. All right, let's try a few more examples here. So now these ones are going to give us 2 more definitions. So alternate exteriors. Alternate means it's looking for anything that creates an N, the letter N, or a letter Z. Now the N and the Z can be also backwards. So the first thing I want to do is I want to identify where can I create a Z. So I'm going to look and create a Z with my parallel lines. That's what you're looking to do. Okay? So everybody find and create a Z. Now, the word alternate means they're going to be on opposite sides of that transversal line. They're not on the same side of the street. Okay? So one guy's across the street. So they're showing us the diagram. The exteriors, the alternate exteriors mean they're going to be on the top of the Z, on the top of the parallel lines. So they're either both on top or both on the bottom. So we're talking about these 2 angles and these 2 angles. Those are your alternate exteriors. Okay, those 4 angles. Okay, they're from a Z. Okay, and the alternate means they come from opposite sides. So if I want to identify specifically this angle, then the only other angle that can match them is the one that is across the street and lower. So across the street and lower would be right there. So those 2 would match. Okay? If I wanted to match the bottom left of the next diagram, he has to match the top right. Okay? And that's how we would match up the alternate exteriors. Now we're going to deal with the inside of our Zs that we drew. So we drew Zs over there. We're going to draw more Zs right here, please. So let's draw a couple more Zs. But now we're going to be dealing with the inside numbers. So these ones are between the parallel lines. Okay, so in between them. So that means on the inside, on the left-hand side of the line, and then the inside on the right-hand side of the line. Okay, so we've got those inside ones. Those are going to be your acute angles, the small ones. Then you've got these bigger ones. So you've got your bigger ones right here, and it's going to match the bigger one out there. Remember, they're on the opposite side of the street. Okay, and we consider the transversal line the street that cuts 2 other streets. So now basically what we've created, if we stick 2 pairs of parallel lines, so that's what this is showing us. I've got 1 pair of parallel lines here, and I know they're parallel because they show me arrows. And I've got another pair of parallel lines because they're showing me arrows as well, going this way. So I have 2 pair of parallel lines. And that is what parallelograms are created from. They're created from 2 sets of parallel lines. So now we're going to identify every single angle in that diagram just from knowing one number. Okay? So, what kind of angle, if I compare 110, what name do I give angle A? He gets a certain name. He's going to be the identical size. So he's going to be 110 degrees, but he gets a certain name. How are they related? They're on the same side of the street. That was one of our first definitions. So what are they called if they're on the same side of the street? Corresponding, starts with letter C. So letter A and 110 are corresponding because they're both on the right-hand side of this parallel line. They're both on the right-hand side of the street. Now we're going to find opposites. How big is angle B? 110, because he's across. He's opposite of A. So he's 110. They have to match. Now, am I able to find, if I were to put a red dot here, am I able to find that number? that would be called an alternate exterior. Exterior means it's on the top of parallel lines. So how can I find that number? Perfect. 180 minus 110. Okay? Because they form straight lines. So that's going to be 70 degrees. And then we're going to use our opposite rule. And the opposite rule says they will be identical. Okay? Well, now I'm going to use a Z rule. I'm going to use my interior alternates. Okay, here's interior alternates. Which angle, I'm going to name them with W and X. W or X, which one of those is 70? X is, because if it's an alternate, it's got to be on the opposite side of the street. So that means X is 70 degrees. Well, then how big is W? He's 110. Now, he's 110 for a couple different reasons. Well, one reason is these two are opposite. Second reason, these two form a straight line. Third reason, these two will always add up to 180 on the inside. So will these two, because they're on the same side of the line. Okay? So there's many reasons and many rules to follow to get the correct answers. Now we're going to run over here. Now, if we remember the parallelogram rules, the small guys match the small guys, and the obtuse angles match the obtuse. So how big is angle C? Right, he's got to match exactly across from him, inside of that parallelogram. And remember, C and this blue dot I'm drawing, those two are going to add to 180. And we can also do an opposite rule. 110 is across from him in a parallelogram. That means they have to be identical. So they're going to be 110 degrees. Okay? Now, D is going to be how big? 70. Now, what rule can we use to prove it? 180. These two make 180. What else could I do? The Z. Good job. I could use my interior alternates, the Z rule. Many different rules to find every angle. Okay? So now this guy across will be 110. This guy across will be 70 degrees. And we're going to do the same thing going up. 70 across is 70. We're going to find a straight line right here. And these two add to 180. So 110 degrees it is. Which means this guy is 110 because across has to match. Okay? This question I'd like you to do for homework. This is the end of lesson B.